Monica, and for my part in this presentation of AC motor is I'm going to talk about the construction of AC synchronous motor, the principle of working, and the last but not least, their characteristics. So let's get started.
Construction of AC synchronous motor. As you can see, these are all the main part of the AC synchronous motor, but the stator and the rotor are the most important one. The stator is the stationary part of motor. It is cylindrical frame which has slots to carry winding circuitry, while the rotor is the rotating part that rotates exactly at the same speed as the stator magnetic field that excited by DC source. It is consists of a number of poles and it is depends on the speed and frequency of the machine. This is the relationship between speed, poles, and frequency. Frequency times time in second over number of pairs of poles equals to speed in RPM unit, which is revolution per minute. Type of rotor construction. There are two types of rotor construction, salient pole rotors and non-salient pole rotors. The salient pole rotors, where the poles protrude from the rotor surface. The non-salient pole rotors, the winding, are placed in slots machine rotors. This is the continuation of the main part of the AC synchronous motor. The stator consists of the core is generally made of lamination of silicon steel. It is to prevent the flow of eddy current. The winding circuit of the stator is called stator winding and it is supplied three-phase AC power. Next, the exciter. The exciter is the small generator that placed in the rotor that provides excitation power for excitation. It consists of the field winding and armature winding. The field winding is placed in stator while the armature winding is placed in the rotor of the machine. Last but not least, the frame. The frame is to protect the motor and covers the whole assembly. Principle of operation. Principle of operation of a synchronous motor is that the rotor follows the rotation magnetic field of a stator at a speed approaching it. The rotor winding is excited by a DC source and the stator winding is excited by AC source. Salient point regarding to the working principle of synchronous motor are as follows. Due to three-phase AC, a three-phase rotating magnet is produced by stator winding. Rotor winding produces a constant magnetic field. In some rotation, the poles of two magnetic fields attract each other while at some instant repel to each other. The rotor will not start to rotate due to its inertia, so an external source will provide initial rotation. When the rotor starts to move at the synchronous speed, the external source is shut off. The magnetic field of a rotor is not produced by the magnetic field of the rotor, but through induction. Hence, the air gap between rotor and stator is not kept very small. Characteristic of AC synchronous motor. There are few characteristics of synchronous motor which are speed, starting torque, rating, efficiency, maintenance, and power factor correction. The speed of ranges from 150 rpm to 1800 rpm. The speed is synchronous and doesn't depend on load condition, which means speed always remains constant from no load to full load. the starting torque. External force is required to start the synchronous motor as it has no starting torque. Rating. Power rating of synchronous motor range is between 150 kW to 15 MW. Efficiency. It is highly efficient machine because synchronous can be maintained as per requirement by changing the excitation of the rotor as the induction motor always runs on a lagging power factor. This means the synchronous motor is much greater than induction motor. Maintenance. Synchronous motor use brushless exciter which decrease the maintenance problem. And the last but not least, power factor correction. Since this motor have high power factor correction, it is mainly used in area where power factor correction is needed. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Intan and I'm from 2ABM4. I would like to proceed with the next presentation, which is my part, the single phase and polyphase induction motor. So, first, what is single phase induction motor? So, single phase induction motors generally have a construction similar to that three-phase motor. NAC winding is placed on the stator. Short circuit conductors are placed in a cylindrical rotor. The significant difference of cost that there is only a single phase supply to the stator. Okay, so motor construction. So the main parts of a single induction motor of the single phase induction motor are stator, winding, and rotor. So the stator is the fixed part of the motor which AC is supplied. The stator contains two types of windings. So one is the main winding and the other one is the auxiliary winding. These windings are placed perpendicular to the other. A capacitor is attached to the auxiliary winding in a parallel. So the main part, stator, rotor, winding, main winding, and starting winding. Okay, so how does the single phase induction motor works? Single phase induction motors main winding is applied with a single phase AC current. This produces fluctuating magnetic flux around the rotor. This means as the direction of the AC current change, the direction of the generated magnetic field also change. This is not enough condition to cause rotation of the rotor. So here is the principle of the double revolving field theory is applied in the single phase induction motor. So according to the double revolving theory, a single alternating field is due to the combination of two fields of equal magnitude but revolving in the opposite direction. So the magnitude of these two fields is equal to the half of the magnitude of the alternating field. This means that when AC is applied, two half magnitude fields are produced with equal magnitudes but revolving opposite directions. So there is a current flowing in the stator and magnetic field revolving to the rotor. Thus, Faraday's law of electromagnetic induction acts on the rotor. According to this law, the revolving magnetic fields produce electricity in the rotor which generates force that can rotate the rotor. So next, I'll proceed with the polyphase induction motor. So what is polyphase induction motor? The polyphase induction motor is the most commonly used industrial motor finding application in many situations where speed regulation is not essential. It is simple and relatively inexpensive, and the absence of sliding contacts in the squirrel cage machine reduces maintenance to a minimum. So, how does the polyphase induction motor works? Polyphase power is particularly useful in AC motors such as the induction motor, where it generates a rotating magnetic field. When a 3 or more phase supply completes one full cycle, the magnetic field of a 2 poles per phase motor has rotated through 360 degrees in physical space. Motors with more than 2 poles per phase require more power supply cycles to complete one physical motors. Using a rotating magnetic field were independently invented by Galileo Ferraris and Tesla, that developed in a 3-phase form by Mikhail Dodivol-Dobzhansky in 1889. So there's only for my presentation for the single phase and polyphase induction motor. Thank you.
Assalamualaikum and hello everyone. My name is Hafiza. I will explain about methods of speed control and direction of rotation. Okay, first, the difference between rotor speed and synchronous speed is called a slip speed and expressed in percentage. The speed of AC motor is governed by the input frequency. To change the direction of rotation of 3-phase motor is by changing any 2 connection of the 3-phase input, thus rotating field will be reverse direction. If all connections be reversed, the rotating field will rotate in a same direction of rotating. The speed of induction motor is changed from both starter and rotor side. Okay. The speed of control of 3-phase induction motor from starter side are further classified as: first, V per F control or frequency control. Whenever 3-phase supply is given to the 3-phase induction motor rotating, magnetic field is produced which rotate at the synchronous speed given by this. In 3-phase induction motor, EMF is induced by induction similar to that of the transformer, which is given by this. Where K is winding constant, T is the number of turns per phase, and F is frequency. Okay, next, controlling supply voltage. The torque produced by running 3-phase induction motor is given by: in the slow slip region, SF2 is very small as compared to R2, so it can be neglected to torque becomes like this. Since rotor resistance R2 is constant, so the equation of torque further reduced to this one. The third one is by changing the number of starter poles. Okay, the starter pole can be changing by 2 methods. Okay, one, multiply starter winding methods, and next, pole amplitude modulation methods. Okay, let's move to the speed control of the 3-phase induction motor from rotor side. Are further classified as: first, by adding external resistance on rotor side. In this method of speed control of 3-phase induction motor external resistance are added on rotor side. The equation of the Q of 3-phase induction motor is the third phase induction motor rotation in a slow slip region. In slow slip region terms, S2 is become very small as compared to R2, so it can be neglected, and also E2 is constant. So the equation of torque after simplification becomes like this. Okay, second, cascade control method. In this cascade operating method of induction motor speed controlling, there are two motor are mounted of the same shaft of the motor and run at the same speed. One motor connected to 3-phase supply and other is worked from the field induced EMF of the first motor through slip ring. By using this method, different speed can apply of induction motor and speed can control. Okay. Next, number third is by injecting split frequency EMF into rotor side. In this induction motor speed control method, external voltage and add into the rotor circuit of the motor and the frequency must be same as split frequency. So injecting EMF in opposite phase of the rotor increase the rotor resistance. By that, this method can use to speed controlling of the induction motor. Okay, last, direction of rotation of induction motor. The direction of rotation of 3-phase induction motor can be changed by simply reversing two of the lead on the motor. The same effect can be obtained into the 2-phase motor by reversing connection to one phase. In a single-phase motor, reversing connection to the starting winding will reverse the direction of rotation. Most single-phase motor designed for general application have provision for readily reversing connection to the starting winding. Nothing can be done to the shape pole motor to reverse the direction of rotation because the direction is determined by the physical location of the Cooper shinding ring. If after starting one connection of 3-phase is broken, the motor will continue to run but will deliver 1/3 the rate power. Also, a 2-phase motor will run at 1/2 its rate power if one phase is disconnected. The motor will start under this abnormal condition. And that's all from me. Thank you and have a nice day.
Now I will explain about the methods of producing rotating field. So in this subtopic, there are three methods to produce rotating field. That is by capacitor, inductor, and shade or split pole. By capacitor, the construction of this side motor is similar to the resistance split phase type. The difference is that in series with the auxiliary winding, the capacitor is connected. The capacitive circuit draws a leading current. This feature is used in this side to increase the split phase angle between alpha and the two current IM and IST, depending upon whether capacitor remains in the circuit permanently or is disconnected from the circuit using centrifugal switch. These motors is classified as capacitor start motors and capacitor start capacitor run motor. When a capacitor is introduced, the voltage lags the current by some phase angle. In these motors, the necessary phase difference between the IS and IM is obtained by introducing a capacitor in series with the starter winding. The capacitor used in these motors are of electrolytic types and usually visible as it is mounted outside the motor as separate unit. The current Im lags the voltage by an angle of m, while due to capacitor the current Ist leads the voltage by angle Ist. Hence, there exists a large phase difference between two currents which is almost 90 degrees, which is an ideal case. During starting, as capacitor is connected in series with the starter winding, the current through the starter winding is led voltage which is applied across the circuit, but the current through the main winding Im still lags the applied voltage V across the circuit. Thus, more the difference between the Is and Im, better the resulting rotating magnetic field. When the centrifugal switch is closed, the magnetic field from the two coils produces the turning force required to run the rotor up to full speed. When the speed approaches 75 to 80% of the synchronous speed, the starting windings gets disconnected due to operation of the centrifugal switch. The capacitor remains in the circuits only at start, hence it is called capacitor start motors. In case of capacitor start, capacitor run motor, there is no centrifugal switch and capacitor remain permanently. This improves the power of factor. The torque developed by a split phase induction motor is directly proportional to the sine of angle between Is and Im. Also, the angle is 30 degrees in case of split phase motors, but in the case of capacitor starts induction run motors, the angle between Is and Im is 80 degrees. It is then obvious that the increase in the angle from 30 degrees to 80 degrees alone increases the starting torque to nearly twice the value developed by standard split phase induction motors. The split torque characteristic curve is exhibiting the starting and running torque of a capacitor start induction run motor. Now we will proceed with inductor. Inductor is an electric motor converts electrical energy into mechanical energy, which is then supplied into different types of load. AC motors operate on an AC supply and they are classified into synchronous, single-phase and three-phase induction and special purpose motors. Out of all types, three-phase induction motors are most widely used for industrial application, mainly because they do not require a starting device. The three-phase induction motors derives its name from the fact that the rotor current is induced by the magnetic field instead of electrical connection. The production of rotating field. The stator of induction motor consists of a number of overlapping windings offset by an electrical angle of 120 degrees. When the primary winding of stator is connected to a three-phase AC supply, it is established a rotating magnetic field which rotates at synchronous speed. The direction of rotation of the motor depends on the phase sequence of supply lines and the order in which these lines are connected to the stator. Thus, interchanging the connection of any two primary terminals to the supply will reverse the direction of rotation. The number of poles and the frequency is applied voltage determine the synchronous speed of rotation in the motor stator. Motors are commonly configured to have 2, 4, 6, or 8 poles. The synchronous speed, a term given to the speed at which the field produced primary current will rotate. It is determined by the following expression. Synchronized speed of rotation is equal to 120 times frequency divided by number of poles on the stator. Now we will continue with production of magnetic flux. A rotating magnetic field in the stator is the first part of the operation. To produce a torque and thus rotate, the rotors must be carrying some current. In induction motors, this current comes from the rotor conduction. The revolving magnetic field produced in the stator cuts across the conductive parts of the rotors and induces an electromotive force, EMF. The rotor windings in an induction motor are either close enough and extremely resistant or directly shorted. Therefore, the EMF induced in the rotor causes current to flow in a direction opposite so that of the revolving magnetic flux in the stator and leads to a twisting motion or torque in the rotor. As consequence, the rotor speed will not reach the synchronous speed of the RMF in the stator. If the speed matched, there would be no EMF induced in the rotor, no current will be flowing, and therefore no torque will be generated. The difference between the stator synchronous speed and rotor speed is called the slip. The rotation of the magnetic field in an induction motor has the advantage that no electrical connection needs to be made to the rotor. Shaded or split pole. Shaded or split pole have a thick loop of copper wire wound around the pole tip cause the rotation. The main field coil builds up magnetic flux in the large part of the pole as the AC current increases, but the build-up of flux is delayed in the small part of the pole because of the inductance of the shading coil. During the next quarter cycle, as the main part of the pole flux is decreasing, the flux in the shaded portion continues to increase in an effort to keep the overall flux from decreasing. This result is the spatial distribution of flux to move from one side of the pole to the other. This apparent motion is what caused the rotor to run. So that's all from us. I hope you all understand about us explaining the AC